Afternoon, students. All of you stay in the call. Let's wait for some more minutes and then we will start the class, okay? Good afternoon, Ramya. Good afternoon, Vaishnavi. Good afternoon, Sankar. All of you stay in the call. After a few minutes, I will start the class, okay? Yes, Vikas, you have raised your hand, it seems. You want to say something? So, students, very good afternoon to one and all. Good afternoon. Good afternoon to all of you. Hope you're all good and safe. So, can you all able to hear my voice? Am I visible and audible? Yes. Okay, fine. So, today we are going to discuss the electrochemistry previous year's questions of JEE and NEET. Okay. So, in electrochemistry lesson, we have come across many topics, right? Like the very most important topics are cold rush law, okay, and then conductivity cell. Then we have studied about electrolytic cell. Then the very, very important is Nernst equation and the relationship between delta G naught and E naught. Okay, Gibbs free energy change and electrochemical potential value. And at last we have studied about batteries and corrosion, right? So like this, we have studied many things in electrochemistry lesson. So from those topics, we are going to cover the previous year's questions today. Okay, today will be the last class for electrochemistry, and from tomorrow onwards, we will start with the new lesson. Got it? So shall we move on to the first question? Are you all ready? So I'm going to give you guys the time for each question, and you are going to solve that question within that time limit. And if you are solving that, you can put your answer in the chat box, and then we will also discuss that in the class. Okay, after the time which I am giving you for each question. Okay, is everything fine and good for all? Shall I move on to the first question? So keep a pen and the notebook with you. Okay, to solve all the questions, to solve the numericals part of each question. So keep everything ready with you. So shall we start with the first question? Yes. Yeah. So here is the first question for you. Yes. Yes, Sakshi. So we have started. Got it. Fine. So the E naught values for Al plus Al couple. Al means aluminium, okay? Aluminium couple and thallium couple, thallium plus thallium and aluminium 3 plus aluminium and thallium 3 plus thallium, okay? So again, this is thallium only. It is not, it is thallium 3 plus thallium couple. So E naught values for all the statements are given, for all the couples are given. We have to find out the incorrect statement from this four options given to you. Okay, option A says that aluminium is more electropositive than thallium. Option B says that thallium 3 plus is a good reducing agent than thallium plus 1. Third is aluminium plus is unstable in solution. Option D says that thallium can be easily oxidized to thallium plus in thallium 3 plus. So, which is the correct option for this question? So, you can solve this question within few seconds itself. So it is such an easy question which you have already studied from the P block concept of class 11. So if you would remember that, you can find out the answer, or by seeing the E naught values also you can get it. Okay. So try for the answer. Let me know the answer in the chat box. Then we will discuss that in the class here. So try for it, try for it. Option A, B, C, D. Which could be the correct answer for this? Not even a single student get the answer for this question. How many of you feel very difficult to solve this question? Just raise your hand or say something in the chat box. Is it very difficult? If you guys are really doing it, then let me know. I'll wait for you. Otherwise, I'll go with the explanation. Shall I go with the explanation or shall I wait, students? No response. Okay, I'll go with the explanation. I'll go with the explanation. Okay. So, if you could remember the information about thallium, thallium plus is more stable than thallium 3 plus. Thallium plus is more stable than thallium 3 plus. So, because the higher members of the corresponding group are stable at their very low oxidation state. Okay, so boron, aluminium, gallium, indium, thallium. So thallium belongs to boron group and aluminium also belongs to boron group. So on moving down the group, if you see, this thallium is the last member of this group. And the higher members are stable at their very low oxidation state. So if we compare plus 1 and plus 3, so thallium is stable at plus 1 only. Okay. So this reason is due to inert pair effect. So this is due to inert pair effect. Okay. So which you might have studied in the P block lesson of class 11. And we have P block in class 12 also. Okay. In that also we can discuss. So thallium is more stable here. So what happens? So thallium, since thallium plus is more stable, so the thallium 3 plus can act as an oxidizing agent. Thallium 3 plus acts as an oxidizing agent. Okay, so what is meant by oxidizing agent? The one which is gaining the electron is called as oxidizing agent. So what this thallium 3 plus will do, it will gain 2 electrons from the species to which is reacting, and then it will be converted to thallium plus. So this thallium plus is gaining this electron, right? So this thallium plus is an oxidizing agent. Got it? So since thallium plus is more stable, it is thallium 3 plus is gaining 2 electrons and it is forming the more stable ion. Got it? Means it is acting as the oxidizing agent. Got it? So if you check for the options here, aluminium is more electropositive than thallium. Yes, that is correct, because on moving down the group, electronegativity decreases and electropositivity increases. Okay, the aluminium 3 plus is more electropositive because aluminium exists in 3 plus form and thallium exists in 1 plus form only. So the more positive charge carrying atom is aluminium. So that is correct. But thallium 3 plus is a good reducing agent than thallium plus 1. No, that is incorrect. Thallium 3 plus is a good oxidizing agent than thallium 1 plus. Okay, so that is the incorrect statement, which is the correct answer for this question. Okay, aluminium plus is unstable. Yes, it is unstable because aluminium is stable only at its 3 plus state. Thallium can be easily oxidized to thallium plus and thallium 3 plus. That is also correct. So thallium can be oxidized easily by the removal of electrons. Okay. So option B is the correct answer for this question. So do you have any doubt from this question? So is this question clear to all of you? Sakshi, Vikas, Sanika, Tazi, what about you guys? Tell me. Tejaswini, Vaishnavi, yeah, yes. Very good. So shall we move on to the next question? Are you all ready? So I hope you guys will solve if the same type of question or if the similar question, if the similar concept related question is asked to you in the next exam or in the next class. Got it? So I hope you guys will answer for this. Very good. So the next question is the molar conductance of NaCl, HCl, CH3COO, Na at infinite dilution are given. Okay, in terms of Siemens centimeter square per mole respectively. The molar conductance of CH3COOH at infinite dilution is. Choose the right option for your answer. Okay, so we have to find out the molar conductance of this corresponding compound at infinite dilution. So what we have to do for infinite dilution, we have to use Kohlrausch law, right? So according to Kohlrausch law, so for infinite dilution, CH3COH, the weak acid, will react with NaCl to produce CH3COONA with the removal of HCl. The removal of HCl. So now what we have to do? We have to find out the molar conductance of acetic acid. So let me take that as X. Okay. And for NaCl, what is the value given here? It is 126.45. So X plus 126.45 is equal to, just equate these two. Okay. For CH3COO it is 91. So 91 plus 426.16. X is equal to 91 plus 426.16. What is the answer? 426.16 plus 96. So one of you give me the answer. So do the calculation fast. 6, 1. Here it is 12. Here it is again 12. So 522.16. So bring this 126 to the other side. So it is minus 126.45. So subtract 126.45 here. So we will get 1 and here we will get 7. Okay. Point. Here we'll get 0, 9 and we'll get 3. Okay. So what we are getting? Very good, very good. So X value is equal to 390.71 Siemens centimeter square per mole. Okay. So option C is the correct answer for this question. Very good, Sanika. Good. So now we all have understood how to solve this question now. So they have given the molar conductance for 3 compounds and we are asked to find out the molar conductance for a one compound. So from the 3 given values, try to form the equation and then get the answer. Okay. So we'll move on to the next question. So any doubts from this question, students? Shall we move on to the next question? Yes. Shall we proceed with the next? Okay. So here is the next question for you. So molar conductance of an electrolyte increases with dilution according to the equation given below. Lambda m is equal to lambda m naught minus A into root C. So this is a straight line equation, right? For strong electrolyte and weak electrolyte, we have studied this. We have also studied this with a graph, no? For strong electrolytes, we'll get a straight line with negative slope. And for weak electrolyte, we will get a curve-like thing. Okay, so that graph is based on this equation only. So here is a question from that pattern. So which of the following statements are true? So we are provided with 4 statements. We have to find out the correct statement from this question. Sakshi, no issues, no issues. So if you can able to attend, you can attend the class. Otherwise, no issues. Just take care of the things for which you have gone for hospital. So it is, you will get all the things in the YouTube. Okay, you can go through later from that also. So students, if you are suffering from any kind of issues like this, and if you're not able to attend the session, so like for this genuine reason, okay, simply you should not do like that. For this kind of thing, you can try to attend, otherwise you can go search it. Okay, no issues. Fine. Yeah. So we are provided with 4 statements and we have to find out the true statement from these 4. And we have to choose one of the options given below. So let's go from the first. So option statement A says that this equation applies to both strong and weak electrolytes. Is it true? No. Because this is a straight line equation where y is equal to mx plus c. And where m is the slope here, it is minus a and x is root c and y is lambda m and intercept is lambda m naught. Okay, so we have got this straight line only for strong electrolytes, not for weak electrolytes. Okay, so this equation is applicable only for strong electrolytes, not for weak electrolytes. So option statement is incorrect. Okay. Then coming to statement B, the value of this constant A is nothing but the slope. Okay, and that slope depends upon the nature of the solvent which we are using. So this is a theory question, theory statement, theory-based statement. So that statement is correct. Okay, so the slope value depends upon the solvent which we are using there for dilution. So that is a correct statement. So if you do not know this, try to take this point in your notebook. Okay, under the conductivity topic which we have discussed. And coming to statement C, the value of constant A is same for both barium chloride and magnesium sulfate. So the value of constant A. So will it be same for these two? What do you guys think? No, right? Because barium chloride on dissociation will get barium 2 plus and 2Cl minus. So here I am getting one cation and two anion. But in case of magnesium sulfate, the dissociation will be like Mg2 plus and SO4 2 minus. So one cation and one anion. So here the number of ions produced is equal to 3 and here the number of ions produced is equal to 2. So if the number of ions differs, then everything will differ. No, slope value will also differ. So again statement 3 is incorrect. Okay. Then when you come to statement 4, the value of constant is same for both barium chloride and magnesium hydroxides. So if I go for magnesium hydroxide, so it can be dissociated as magnesium 2 plus and 2OH minus. So one cation and two anion. So the number of ions produced is 3. So barium chloride and magnesium hydroxide both are having the same number of ions. So the A value is same. Option statement 4 is correct. So how many statements are correct here? Option statement B and statement D. So they are correct. The remaining two are wrong. So which is the correct answer? Option D is the correct answer for this question. Okay, very good, Seneca. Very good. So students, shall I move on to the next question? This is okay? Clear to all? Question sometimes they look lengthy, but they are very easy only. Okay, if you understand the theory part as well as all the concepts which is there in the particular lesson, you can answer those things easily. Don't get scared on seeing a lengthy question in your question paper. Okay, so the concept which is present inside that question will be very small only. Okay, so don't skip the question if they look lengthy. Got it? So shall we move on to the next question? Yes or no? Yes or no? Say something. Mahek, Tejaswini. Yes. Okay, good students. So here is the next question. So if you see to this question doesn't have options. Means it is one of the J mains question. Okay. Okay. Mostly in J mains we have numericals, right? Where where you are not provided with any option. So this is J question. So the question says that the resistivity of a 0.8 molar solution of an electrolyte is 5 into 10 to the power minus 3 ohm centimeter. Okay, so what is this value? It is resistivity. Resistivity is denoted by the letter rho. And the concentration of the solution is also given in terms of molarity. So it is denoted in terms of capital M, no? So it is given in terms of molarity. So its molar conductivity is dash into 10 to the power 4 per ohm centimeter square mole inverse. So what is meant by molar conductivity? Lambda M. So we are asked to find out the lambda M value from the given values. So what is the formula to find out the lambda M? Lambda M is equal to kappa into 1000 divided by M, right? So this is what we have studied now in the molar conductivity formula. But we are not provided with the kappa value. Kappa means conductivity. Instead of conductivity, we are provided with resistivity value. So we know that kappa is nothing but the inverse of resistivity. Conductivity is the inverse of resistivity. So in place of one kappa, I can substitute 1 by rho into 1000 divided by m, which is equal to 1 by 5 into 10 to the power minus 3 into 1000 divided by 0.8. So if you calculate this, you will get, so has anyone calculated the answer for this? One of you try the answer for this. You have to give the answer in terms of 10 to the power 4. Okay, 10 to the power 4. One of you try the answer for that in terms of 10 to the power 4. It is plus 4, no? Sorry, it is plus 4 per ohm centimeter square per mole. What is the value of X? Let me take this dash as X. Find out the value. Okay, you can solve it later. Okay, so let us not waste the time. I'll give you the answer and later on you check whether you're getting that answer or not. So you will get 25. So answer will be 25 into 10 to the power plus 4. 2.5 Sanika, no, in terms of 10 to the power 4 you have to give. It is 25. Okay, so just check once again. You will get 25. There is a small mistake with your decimal. So don't do that mistake again. So see to your mathematical thing. Okay. Very good, Sanika. You have tried for the answer, I think. Others are also trying, but they are not giving their answer in the chat box. Fine. So let me move on to the next question. The correct value of cell potential in volt for the reaction that occurs when the following two half cells are connected is. So for Fe2 plus, we have one E naught value, and for dichromate ion Cr2O7 2 minus, we have another E naught value. Fe2 plus has gained some electron and it has got converted to Fe. Okay. Chromium also same thing. So chromium is present in its plus 6 oxidation state and then it is coming to a plus 3 oxidation state. So we are asked to find out the cell potential in terms of volt. So how to find out the cell potential? What is cell potential? It is E naught cell. So this is what we have to find out. So it is nothing but the E naught of cathode minus E naught of anode. So okay. So who is the cathode here? In cathode, reduction occurs, no? So it is chromium. So 1.33 minus E naught of anode. So the first reaction where the oxidation occurs. So it is 0.44. If you add these two, you will get 1.77 volt plus 1.77 volt as the value for E naught cell. So option A is the correct answer for this. Clear? Students, very easy, no? That's an easy question. Shall we move on to the next? Shall we move on to the next? So the each term with the symbols, that is the main thing you have to practice here in electrochemistry. Got it? So then only you will be able to know which is asked and which formula has to be applied. Got it? So shall I go for the next question? Say yes or no? Yes or no? Yeah. Okay. The conductivity of centimolar solution of KCl, potassium chloride at 25 degrees Celsius is 0.0210 per ohm per centimeter. And the resistance of the cell containing the solution at 25 degrees Celsius is 60 ohm. The value of cell constant is. So what is cell constant? Cell constant is denoted by the letter G star and it is equal to L by A. So we have to find out L by A here. Okay, and the conductivity of the centimolar solution. So what is in the centimolar solution? Centimolar solution means it is 1 by 100 molar, which is nothing. Because centi means it is 10 to the power minus 2, which is nothing but 1 by 100. So it is equal to 0.01 molar. So this is the concentration. Okay. And the conductivity of the solution is given as 0.02. So conductivity is denoted by the letter kappa and it is equal to 0.0210 per ohm per centimeter. Okay. And the resistance of the cell is also given. Resistance means it is R. It is equal to 60 ohm. The value of cell constant is. So to find out the cell constant, you need to find out the resistance value, or you need to find out the, what to say, L by E, right? So the in which equation or in which formula L by A is related with the given values kappa and R. So only in one equation, right? So that equation is kappa is equal to 1 by R into L by E. So this is the formula which relates L by A and conductivity and resistance. So substitute the values here. Kappa is equal to 0.0210, which is equal to 1 by 60, and L by A. So we are asked to find out L by A. So what you do, take this 60 to the other side and multiply it with the 0.0210 number. So from that, L by A value will come out to be 1.26 centimeter inverse. So option B will be the correct answer. Okay, clear? So is it clear for all of you? Yes. Good students. Here is the next question. Given below are two statements. One is labeled as assertion and the other is labeled as reason. Assertion says that in equation delta GR naught, GR is equal to minus NF E cell, the value of delta G depends on N. Is it right or wrong? Delta G depends on the N value. What is N here? Number of electrons lost or gained. Obviously, it depends on N because they are directly proportional, no? So, if the N value changes, if the number of electrons lost or gained changes, then obviously delta G will also change because the number which we are going to multiply with F and E will change, right? With respect to N. So, delta G will also change. So, assertion is correct. What about the reason? E cell is an intensive property and delta G is an extensive property. So, what about this reason? So, what do you say about this? Whether E cell is intensive and delta G extensive is correct or wrong? So, what is meant by intensive property and extensive property first of all? So, in class 11 thermodynamics lesson, you might have studied about this. So, the properties whose value depends on the amount of the substances are called as extensive property, and the properties of the system whose value does not depend on the amount of the substance are called as intensive property. So E cell value is an intensive property and that is correct because E cell doesn't depend upon the amount of the substance which we are having in the beaker. Okay. But delta G is an extensive property that is also correct because it depends on the number of electrons lost. So delta G is dependent on the number of electrons means the quantity, the amount. Okay, it depends on the amount. Delta G depends on the amount. So that is why that is what is given as the assertion here. So both A and R are true and R is the correct explanation for A. Very good, Tazeen. Option D is the correct answer. Okay, students, you are doing great. Very good. I hope you all of you have understood this question. Shall I move on to the next? Shall I move on to the next question? Yes, I'll move. Two half cell reactions are given below. One is for cobalt 3 plus to 2 plus, and the couple is given for 2 plus to 3 plus. Okay, E naught couple. And the other one is moving from aluminium 3 plus to aluminium. And here aluminium to aluminium 3 plus couple value is given. So we are asked to find out the standard electromotive force of a cell with feasible redox reaction will be. So here if you see, so just look for the E naught value. For the cobalt couple, it is negative, and for aluminium couple, it is positive. Okay. So both the couples are oxidation potential, 2 plus 2, 3 plus 0 to 3 plus means oxidation potential. But the aluminum oxidation potential is more because it is given in terms of positive value. No. So since the aluminum or the E naught value of oxidation potential of aluminum is more than the cobalt 2 plus, so what happens? Aluminum will get oxidized at anode and cobalt will get reduced at cathode. Okay, so aluminum will be oxidized and cobalt will be reduced. Now to find out the E naught cell, what we have to do? E naught of cathode of reduction potential minus E naught of anode in terms of their reduction potential. Okay, so reduction potential means E naught of reduction means more positive number to less positive number. One of you have got the answer or what? Option A, Ramya? No, option A is not the correct answer. Let's check. Minus E naught of aluminum 3 plus 2 aluminum. This is called as reduction. Okay. So this is called as reduction. Option D. Okay, let's check this one. So if you go for the reduction, but these two are the oxidation potential, no? So if you want to convert those two into reduction potential, just change the sign. Just change the sign. Yeah. So change the reduction potential, oxidation potential sign. So minus means it is plus 1.81 minus of, here it is given as plus. So you have to put minus of 1.66. And if you add these two, you will get 3.47 volt. Where option D is the correct answer for this question. Okay, two of you have given me the correct answer. No, Vaishnavi and Tejaswini. Very good. So Ramya, did you notice the mistake that you have made? Yes? Yeah, very good. Super. Good, my dear. So we will move on to the next question. So you have to be very careful, okay, with the E naught value. So you have to check whether they have given for the reduced part or the oxidized part. Okay, accordingly you have to substitute. So one more question from James. For the galvanic cell, zinc plus copper 2 plus giving zinc 2 plus and copper, E cell is equal to dash into 10 to the power minus 2 volt. And some values are also given here. So how to find out the E cell? How will you find out the E cell? From the next equation only, we can find out the E cell, no? So E cell is equal to E naught cell minus 0.059 divided by N into log of Q. Okay, this is what we have studied in Nernst equation. So what is this Q? Q is the reaction quotient where it is equal to the oxidized ion divided by the reduced ion. Now from the given equation which has been oxidized, zinc has got oxidized now from 0 to 2 plus. So the oxidized ion is zinc 2 plus. Write its concentration in the numerator, the whole divided by the reduced ion. Reduced ion is copper 2 plus. Its concentration. Okay, so what are the concentration of these two ions? Zinc 2 plus concentration is 0.04 and copper 2 plus is 0.02. So you can cancel out this and you can get the Q value as 2. So substitute Q value as 2 here. E cell is equal to E naught cell. So just check whether E naught cell value is given here or not. So the E naught cell for this zinc copper couple, we all know, right? It is 1.1. E naught cell for this couple is 1.1. This value we have already discussed in the class. Okay, from that only I am taking this. This is a very common number. So you have to memorize. Okay, you do not expect to give the value in the question. So for zinc copper, E naught value is 1.1 minus 0.059 divided by the number of electrons lost is 2 or the number of electrons gained is also 2 into log of 2. Okay. So what is log 2 value? It is 0.3. So multiply, divide and subtract by doing all the mathematics. We will get and it will be approximated. We have to give the approximate value in terms of 10 to the power minus 2, right? Into 10 to the power minus 2 volt. So it will come out to be 109 into 10 to the power minus 2. So the value that we have to find out here is 109. Okay, clear for all of you? You can memorize this value or you can get from the given thing also. Okay, oxidized potential value for zinc is given and the oxidized potential value for copper is given. So just add those two, you will get. Clear? Shall we go with the next? Yes or no? Any doubt from this question, students? Okay, the next question is the standard electrode potential for the cell with the same reaction is given and the value is given as 1.1 volt. Okay, calculate the standard Gibbs energy change for the cell reaction. So here what we are asked to find out, the delta G naught value we have to find out. So what is the formula? Delta G naught is equal to minus NF E naught cell. Okay, so what is the n value here? Number of electrons lost is 0 to 2. So it is minus 2 into Faraday. Faraday's constant is given 96,487. Approximately you can keep it as 96,500. But in the question they have given the value, no? So you can substitute it directly, the exact answer, and into E naught cell. E naught cell is given as 1.1. Okay, so just direct multiplication. One of you multiply the values and give me the answer in terms of joules and in terms of kilojoules. First, give me the answer in terms of joules because we are provided everything with joule only. No? Has anyone multiplied? 2 into 1.1 into 96,487. One of you have got the answer? Minus 212271.4. Very good. So this is the answer in terms of joules or kilojoules, Ramya? The answer you're giving for joules or in terms of kilojoules? This minus 212271.4. Mahek, you are getting option B. No, my dear. This is the value which is given in terms of joules, joules per mole. If you want to convert this into kilojoules per mole, you have to move the decimal, 3 decimal here. So it will be minus 212.27 kilojoule per mole. Okay. So option C will be the correct answer. Okay, Ramya, you have given in terms of joules. Very good. So option C will be the correct answer. Got it? So in terms of joules, we will get a 6-digit number. So this is the answer for this question. Now let's move on to the next question. Very easy. Straight away, substitution and then multiplication. Nothing to worry and struggle here. Okay. So next question number 11. Okay, this is 11th question I can say. Find the EMF of the cell in which the following reaction takes place at 298 Kelvin. Nickel silver reaction is given. Concentration of the corresponding ions are given. E naught cell value is given and we are asked to find out the EMF of the cell. Actually, this was the question asked in 2022 or 2023, I think. 2022. Neat 2022 question it is. So here all the options are actually wrong. Okay. So the correct value will be, it will be what to say. Actually, the option A was turned to the correct option. So here this number was wrong. It is not a printing mistake. Actually, in the question paper itself, it is wrong. Okay, it is not the printing mistake here in this slide. In the neat question paper itself is wrong. So it will be 10.4115 volt. This is the correct answer. So now here you are going to tell me which formula has to be applied here to get this correct answer to find out the EMF of the cell. Tell me which relation you will use here. Which formula we have to apply to find out the EMF of the cell. EMF means E cell. Okay. So what you have to do? E cell is equal to Nernst equation you have to use. What is Nernst equation? E cell is equal to E naught cell minus 0.059 divided by N. Very good, Ramya. This Nernst equation into log of oxidized ion, which is nickel 2 plus concentration divided by silver. Silver is getting reduced now, Ag plus concentration, but we are having 2 Ag. So it is, the 2 has to go to the power. Okay. So E cell is equal to E cell is equal to E naught cell value is given here. It is 10.5 minus 0.059 divided by 2 because the number of electrons lost or gained is 2 into log of oxidized ion concentration is 0.001 and the reduced ion concentration is also 0.001. But here power is there. So this entire term can be written as 10 to the power minus 3 because you can bring the decimals here. And here it will be 10 to the power minus 3 square. So it is 10 to the power minus 6. Okay. So 3 gets cancelled here. So the 10 to the power minus 3, if it goes to the numerator, we will get 10 to the power 3. So 10.5 minus 0.059 by 2 into log of 10 to the power 3. So log of m to the power n formula, which is n into log m. So the answer for this entire term will be 3. Okay. So multiply, divide, and 10.5 minus 0.0295. So if we divide this, we will get this number and into 3. So multiply this with 3 and subtract it. So here we will get 10.4115 volt as the E cell value. Okay. Clear now? All of you know this formula, right? Log of m to the power n is equal to n into log m. So you get log 10 here. Log 10 value will be equal to 1. Okay. So 1 into 3 is 3. Is it all right for all of you? Any doubts? Tejaswini, Mahit, Vaishmani, Janavi, Pratyusha. Why you guys are not speaking? Rutuja, Kritika, Surya Gauda. Is everything clear? Can you all able to understand? Clear? Okay. So let's go with one more question. For the cell reaction, 2Fe3 plus 2I minus giving 2Fe2 plus I2, E naught cell is given as 0.24 volt at 298 Kelvin. The standard Gibbs energy of the cell reaction is. So what we have to find out? Standard Gibbs energy, delta GR naught we have to find out. Very easy, and the relation also you all know. So delta GR naught is equal to minus NF E naught cell. So all of you do so apply all the given values and give me the answer in the chat box. What is the value of N here? How many electrons are lost? Fe3 plus is getting converted to Fe2 plus by the release of one electron. But 2 Fe3 plus is getting converted to 2 Fe2 plus. So for one Fe3 plus only one electron is lost. For 2 Fe3 plus 2 electrons will be lost. So the number of electrons lost will be 2. Okay. So N value is 2. Faraday's value here they have given in terms of coulomb per mole and it is 96,500 into what is the E naught cell value? 0.24. So multiply everything. Multiply the value and give me the answer. Multiply everything and tell me which is the correct answer. In terms of kilojoules, we have all the options in terms of kilojoules. So here you will get the answer in terms of joules and you have to convert that to kilojoule and get the value for delta GR. Okay. Has anyone got the answer? Option C. Very good, Mahis. What is the answer? What is the answer for this? In terms of joules. 46320. Very good. So it is minus 46320 joule per mole. Okay, so to convert this, move 3 decimal. So it will be minus 46.32 kilojoule. Okay, which is the value for delta GR naught. So option C is the correct answer for this question. Very good, Jitendra and Ramya. So it is option C. It is option C. So Jitendra have forgot the minus, I think. So if you have forgot this minus, you will go with option A. Okay, don't try to put the minus there. Okay, you also have an option with the positive number, no? So it is minus 46. Option C is the correct answer. Got it? Is that okay? So now let me move on to the very last question for today's session. Okay. So here is the last question for you. The molar conductivity of a 0.5 mole per decimeter cube solution of AgNO3 with electrolytic conductivity of 5.76 into 10 to the power minus 3 Siemens per centimeter at 298 Kelvin is. So what we are asked to find out? The molar conductivity is. So we have to find out the molar conductivity lambda m. So how to find out? We are provided with the electrolytic conductivity value. Electrolytic conductivity means kappa. So we have to find out molar conductivity. So lambda m is equal to kappa into 1000 divided by m. So which is equal to kappa is 5.76 into 10 to the power minus 3 into 1000. What is the concentration? 0.5 mole per decimeter cube, which is nothing but number of moles per 1 liter. 0.5 moles is present in 1 liter of the solution. Okay, 1 decimeter cube is nothing but 1 liter. So it is 0.5. Now, if you solve this, all of you solve this, do the multiplication. Here it is 1000 and 10 to the power minus 3. 1000 is nothing but 10 to the power plus 3. So they will get cancel out each other. So 5.76 divided by 0.5. Is the correct answer? Very good. Very good, Sanika, very good, Ramya. So option, so all of you have got the answer. Janvi, very good. It is very good. Option B is the correct answer. Very good, Jitendra. All of you are doing really great. Students, very good. So it is 11.52 Siemens centimeter square per mole. Option B is the correct answer. Good and great. All of you are doing good. So I'm closing the today's session here with this question. I hope this session is very useful for you, and I hope you all can able to understand how to apply the concepts which we have studied in this lesson. Am I right? Do you have any doubts? Like how to apply the thing which we have studied? No. Okay, fine. So like this, what you have to do, you have to solve at least one question per day from electrochemistry lesson and from solutions lesson. Yeah, then only you will be able to solve all type of question. Whatever might be the type of question is being asked in the examination, you will be able to solve if you are in practice, if you are in the consistent practice with each lesson. Okay, so take some question solving book and do practice at least one question per day from both the lessons. Okay, so here we are completing the electrochemistry, and from next class we will start with the new lesson. Log values For log 2, log 3 and all, it is very easy, no? For log 2, it is 0.3. For log 3, it is 0.4. For log 5, it is 0.6 something. Okay, so for this very common values, you should know. So if some bigger numbers are there, then they will give the log values in the question itself. Okay, you don't have to, for greater than 10, they will give. So mostly you will not get questions like that. If you are getting questions like this, then they will be you will be provided with the log values. Okay. Yeah. Okay then. Thank you, students. Any other doubt? Do any of you have? Okay. Thank you, students. Thank you so much. Take care. See you all in the next class. Bye bye.